All right, so 3.2 was all about how we solve quadratic functions, quadratic equations. And you learned lots of different methods on how to do that. Completing the square, factoring, the quadratic formula, and we learned how to do all of that. Today, we are going to be graphing these quadratic functions. And one of the things that's kind of nice about our quadratic functions is a lot of it we've already kind of dealt with in some form or fashion in previous sections. And so a quadratic function is going to look like this f of x equals a times x minus h squared plus k. This is a really nice format if it's given to you in this format. And the reason why is because it's going to give you your vertex of your parabola. It tells you your axis of symmetry. And with that coefficient, that a value, you know whether or not it's going to open up or down. And so you know a lot of good information immediately, straight off the bat, about your parabola if it's given to you in this format. So this is a really user-friendly format. It's kind of like y equals mx plus b for our lines. This is the really nice format for our quadratic. So just as a refresher, if your a is positive, you have a upward opening parabola, which means you have a relative minimum down here at your vertex. Your axis of symmetry will always run through the x value of your vertex. If your a value is negative, then it will open down. Everything else still holds, except instead of a minimum, you will now have a maximum that happens. So all of that is really, we've had this information before. So nothing too strange, too crazy, too difficult. So we're going to have some questions about these. We're going to find minimum, maximum, symmetries. We're going to find all the different pieces. And then we're going to learn how to graph with all these different pieces. And I gave Cartesian coordinate systems on this paper, this handout, so that should hopefully help us progress through this. There was a lot of like steps and things like that, which is why I went ahead and just made a handout for this one. So the first style of problem that you may encounter is where they give you the formula of your quadratic, and then it asks you to find the vertex, the axis of symmetry, and either the relative max or min, depending on what kind of a parabola you have happening. So for this first one, we actually don't even graph it. We're just going to find all the bits and pieces where we could theoretically graph it if we needed to. And so the first one is our vertex. Our vertex is our HK. And luckily, this problem gives it to us in the nice format, the a times x minus h squared plus k. So what would be my vertex then for this specific problem?
Would it be 1/4 -2?
That is correct. It is 1/4 -2. And the 1/4 is positive because in our general equation, we have a minus h. So if it says minus a number, that means that's actually a positive value. And if it says plus that number, that will actually be a negative. So it's kind of opposite there. This actually goes back to our horizontal shifting, if you think back to 2.5, with all of our translations of functions. That stuff's going to come back up today, the translation of functions, because really what we have in this generalized formatting is we have a horizontal shift, a vertical shift, and we have a vertical stretch or shrink happening, is what's happening here. So it's really just x squared with all these different translations happening upon it. But yes, our vertex would be 1/4 -2. The vertex being at 1/4 is one of the reasons why we don't actually graph this one, is I didn't want to make itty-bitty tiny tick marks. Now your axis of symmetry, which I call my AOS, will always be x equals your h value. So whatever your h value, the x value is of your vertex, and that's going to be your axis of symmetry. That's where if we fold our graph right on top of itself, it's going to lay perfect. And so x equals 1/4 is your axis of symmetry. Now the last thing we have to find is a relative max or min. So if I'm looking at this generalized equation up here, what is the a? Going back to this one. What is my a? My a is 3. So that is greater than 0. So is it going to open up or down? It opens up. because if it's a positive value, our parabola opens up. The reason why I make note of this is because it's going to tell me if I'm going to find a minimum or a maximum. And in this case, because it opens up, I'm going to be finding a minimum. So the minimum happens at the y value, because it says find the relative min and max. So here's what happens. It's going to happen at, I said that backwards. It happens at the x value, but it has a value of the y value. So when we have our function, if it opens up, right here is our minimum. Where it happens on our graph is determined by our x value, but the value of our minimum is determined by the y value of that. So the value of our minimum is going to be the k value. And so our k value is -2. That is the value or the worth of our minimum. If it just asks you for the ordered pair of your minimum, then really you're just giving the vertex again. So it's not going to ask it quite that way. And we can pull up the homework at the end and see exactly how it's asked. But most of the time, I know on my paper pencil test, the way that I ask it is I ask, where is the maximum or minimum happening and what is its value? And so the where is the x and the value is the y, is how it's going to come out. But for all this information, the only thing we really had to find, we had to find the vertex, and then the axis of symmetry is the x value. The value of the minimum or the maximum is going to be your y value. And then knowing whether or not it's a max or a min is just determined on if A is positive or negative. So lots of different details, all coming really from one piece of information, which is the vertex. Questions on this? Most of the time, you'll be asked for different pieces of this information, and then you will also go on and graph. Okay. If you like steps, here's our steps. This is if you are given the general form of ax squared plus bx plus c equals 0 for your function, or it says f of x equals all of this. If you're given any other format besides the a times x minus h squared plus k form, you're going to want to get it into this form, at least for right now. And the way that you do that is by completing the square, which is what we did in 3.2. By completing the square with the ax squared plus bx plus c, we're able to manipulate the equation around so it looks like this nice format, which gives us our vertex. And then after we have the vertex, we can do either a point plotting system, or we can look at that format and say, okay, what translations are happening? And so what's actually happening with my graph, and that will help me to determine where to plot some points. So we're going to have to complete the square. We'll find the vertex, we plot it, and then we either use the information of what's happening, or we're going to plot some additional points. Remember, when you plot additional points, those are ones that you get to pick. But once you have the vertex, you kind of know which points then lie on either side of your vertex that you might want to be testing. So, given f of x equals x squared plus 10x plus 23, we're going to find all of the pieces, just like we just did on the last one, and we're going to graph it. But the first thing we need to do is we need to rewrite this function in a nice format, because right now it's not in a nice format. So we have f of x equals x squared plus 10x plus 23. And if you remember from my 3.2 lecture, the way that I usually approach this is I make a list of my b, my 1/2 b, and my 1/2 b squared, because that's going to allow me to fill in my completing the square that I need to do. And this one may look a little different than the completing the squares that we had from 3.2, because in 3.2 we had them equal to 0. And so our first step then was to move our constant, and then we added to both sides. We don't have this equal to 0, we just have an f of x. And so when it's not set equal to 0, what we're going to do is instead of moving our constant to the other side, what we're going to do is we're just going to leave a gap where we put our plus and our minus all together on the same side. And I'll show you what I mean. Okay? So I'm going to have f of x equals x squared plus 10x, and then I'm going to put plus a blank, minus a blank, plus 23. Because if I had this equal to 0, what would happen is I would have this 23 over on the other side, and I would have this minus blank, but it would be over on the other side as a plus. And so instead of moving things around because it's not equal to 0, I'm going to put plus and minus, and those blanks are the same thing that we did in 3.2. It's the 1/2 b squared that we're putting in here. And we're going to put the same value in both of those because if you add, let's say 2, and you subtract 2, are you actually adding or subtracting anything to that? No, because it'll cancel out. But what it's going to allow us to do is it's going to allow us to do our completing the square and get our equation into this nicer format that we're trying to get to. So over here, I'm going to have b, which in this case my b is 10. My 1/2 b is 5. So my 1/2 b squared is 25. So what I put in these two blanks is 25. What that is allowing us to do is these first three terms then, right here, will be that perfect square that we're looking for. That's going to give us the x plus the b, or the 1/2 b. That goes in there, squared, and then we have a negative 25 plus 23, which gives me a negative 2. Again, this looks slightly different than our completing the square from 3.2 because everything's all on the same side. But this looks like this nice format that we're looking for. We have our h in here, we have our k out here. There's no a necessarily because our a is 1 in this case. But we were able to get it all into one nice format so we can find our vertex and we can graph from here. Yes?
I did this, but instead of, I didn't realize that it's f of x equals the quadratic. So I just like subtracted the...
You move the 23 over?
Yeah, and then I got the same result.
Yeah, you can do that. It's really not going to mess up anything unless you go on to keep trying to solve it. Just don't keep trying to solve it. Like, once you've completed the square and you move everything back over, it's going to look the same. Yeah. So you'll be okay. So if I'm going from here, what would be my vertex?
-5, -2.
Yep. -5, -2. And then since there's no a written out here, you can consider that to be a 1, which is positive, which means my parabola is going to open upward. I do need to find, because it's asking me for all the things, so my axis of symmetry will be what? Yep, x equals -5. And you don't have to graph that on your graph anywhere. They just might actually ask you for the equation of the line. And if they ask you for the equation of the axis of symmetry, you can't just put -5 because that's not an equation. You have to put x equals. So be careful on that. So we did vertex, we did axis of symmetry. Relative max or min, since it opens up, we're going to have a minimum again. And it has a minimum value of what? Yep. That's going to be your k value or the y value of your vertex. Now I may have to I don't think I'll cross over any of my math over here. Because if I'm plotting my vertex, that'll be at -5, -2, which is over here. We know it's going to open up. And so really from there, we're probably pretty good. And here's the nice thing, is this is an x squared with a horizontal shift to the left 5 units, down 2 units. It all jives with our 5 or 2.5 material. It all works. So that would be our vertex. We're going to open up. If we needed to get a little bit more technical with this, what we could do is we could find some other values. Because once I've plotted this, I'm like, okay, I'm at 5, -5, -2. So what happens when x is -4 or -6 or -3 or -7? Because since it's a parabola, these two values and these two values should be the same. So if I put -4 into this, I'm taking 1 squared, which is 1, minus 2. That should give me a -1 for both of those. And then if I put -3 in, -3 plus 5 is a +2. 2 squared is 4. 4 take away 2 is 2 for both of those. So I should be at -1, -1, and I should be at +2, +2. That's how you can find some additional points to make it a little bit nicer instead of just doing what I did on this previous problem where I plotted the vertex and I just kind of made it U. This one's a little bit more technically accurate because I found a couple additional points. The completing the square and thus finding the vertex is really the hardest bit. It's the one that takes the most algebra. Questions? We will do another one. All right, let's flip it over. You can't see that? There you go. This one looks a little different, which is why I like to include it. Nothing is changing on this one. We're still going to complete the exact same steps. We're going to find exact same pieces. But this one, we have x squared over 2 minus 4x plus 8. And so that x squared over 2 looks weird because usually we put a coefficient out front. And so I would start off by rewriting that. Because if it's x squared over 2, that's the same thing as saying 1/2 x squared. Now, when we complete the square, we have a problem. Because if you remember, and maybe you don't, and that's okay, but when we complete the square, if a does not equal 1, then we have to divide both sides by this a, because we need the coefficient of our a term to be 1. And so the problem becomes, well, we can't divide both sides by the a because we don't have two sides. We're given a function that we're trying to play around with. And so what we're going to consider or do is we're going to ignore our constant because we end up scooting it to the side. You know, that would be the term we would move over. And we're going to factor that 1/2 out of our first two terms before we complete the square. So we're going to take the 1/2 out of those. And before you get mad, I promise you won't have to do this but like once. And the way you check is you distribute the 1/2 back in and make sure you get back up to that top. It looks weird, I know. But this is how we're getting that a term because we're trying to get to f of x equals a times x minus h squared plus k. So really, we're going to kind of ignore that 1/2 out there for a while. It lives out there, but it's just going to hang out. And what we're going to do is we're going to worry about in here. We have the x squared, we have the minus 8x plus blank minus blank plus 8. And notice the plus and minus both happen inside of the parentheses because we're completing the square after we've already factored out the 1/2. So I'm running out of room, so I'm going to come up here. My b in this case is not the b that I started with. It's the b that I have right now. And the b that I have right now, you cannot see, is -8. So the 1/2 b is -4. And the 1/2 b squared would be a +16. That's what's going to go in both those blanks is 16. Now, obviously, when we are completing the square, we are concerned, or when we're doing our perfect square factoring, we're concerned with these three numbers. So the reason why I stick this negative in here, though, is because I don't want you to just think, okay, I've got to subtract the 16 from the 8. Because that's going to forget that we pulled out a 1/2 first. What really ends up happening is you have the 1/2 here with the x squared minus 8x plus 16. The 1/2 times the negative 16 gives you a negative 8, and then you have the plus 8 out there. You have to distribute that 1/2 before you're going to add it to the constant. I know it's weird. It doesn't play by all the rules that we usually play with because it's a little bit different, which is why I included in the notes. When we factor this perfect square trinomial, we'll get the x minus, or it's the x plus the 1/2 b. So in this case, it was a minus 4 squared. And then the negative 8 plus 8 goes away. And that's okay. Because remember, this plus out here is our k value. And our k value can be 0. That just means we're going to lie right on an axis. And as weird as all of this was, we did get down to the format we were looking for. We got down to the ax minus h squared plus k. The vertex is your hk, so in this case it's 4, and there's no plus out here, so it's 0. Your axis of symmetry happens at x equals whatever your h value is, so in this case it's 4. And since our a is positive, again we have an upward facing, so we have a minimum value of 0.
Isn't that supposed to be negative?
So our standard equation has a minus in here, and so we just look at the h and the k. So this one already says minus, so since this still says minus, that actually means that the x value is positive. On the previous example, we had a plus 5 in here, which is the same thing as saying x minus a negative 5, which is why our h value was negative. So that is always going to go opposite. Now we have all of the pieces to kind of start graphing. 4, 0 is our vertex. We know that it opens up. And so from there, I could look at my x and my y to figure out a couple more points. I could find out what happens at 5 and what happens at 6 so that I know what happens around it. If I plug in 5, 5 minus 4 is 1, so that's going to be 1/2. If I plug in 6, that'll give me 2. 2 squared is 4. That'll give me 2. So it like barely moves for 5 and 3, but then I'm up at 2 for 6 and 2. Not all of your parabolas will open up. It just so happens that the two that I chose right here do. And before you all go on strike because you hate completing the square, and especially you hate completing the square whenever we don't get to set it equal to 0 and play with it nicely, this is the hardest way to do it. And usually if there's a hardest way to do it, through the generations, enough mathematicians have gone crazy to come up with an easier way to do it. And they have. And you will love it because it's so much easier. You can find the vertex of a parabola by doing negative b over 2a for the h value, and then plugging that into the function itself to find out what the y value is at that given value. No completing the square necessary. No rewriting anything. No weird pulling out because a is a wrong number. None of that matters. A can be anything, and so you can leave it alone. This is the way that you are going to want to graph these. This is the way you can find all of the same information that we've been finding without all the headache. Negative b over 2a and then f of negative b over 2a. So the only thing we need is actually we want our parabolas to be written as ax squared plus bx plus c now. We don't have to worry about that other special formatting at all. We can do with this. So if they give it to you already in this format, you can find the information. You don't have to move it around. You don't have to distribute. You don't have to do anything. You can find all the information and you can graph straight from that. If they give you this format, which is honestly the most common formatting that you will see, because this is the one that's ready for you to solve your quadratics, then the negative b over 2a and f of negative b over 2a is the easiest way to go. So let me show you how that works. We have negative x squared plus 14x minus 47. So if we were doing the other method, we would have to factor out that negative, then we would do our completing the square and move on. But with this new method, I'm going to list my a, b, and c, just because I'm a little OCD and can't not list the c. So my a in this case, there's just a negative in front of the x squared, so it's a negative 1. My b is 14. My c is negative 47. So I list those out to the side. And the first thing I need to find is I need to find my negative b over 2a. That's my h value. And that's what I have to find first. So negative b would be negative 14 over 2 times my a, which is negative 1. Negative 14 over negative 2 will give me a 7. So that is my x value, or my h value, of my vertex. So if I had to find my axis of symmetry, right there. Found it. But that's only half of my vertex. So, because a vertex is an ordered pair, so this will be the 7. Now I have to find the k value. And so the way that I do that is I find f of negative b over 2a. That looks weird, but what I'm doing is I'm finding f of 7. We've done that. That's where we take our function, and anywhere there's an x, I'm going to put a 7 in, and I'm going to compute it. Now, look at this, though. Be careful here. It says negative x squared. That negative is not included in the squared part. There's no parenthesis. So it's negative 7 squared, like this, plus 14 times 7 minus 47. Gives you a negative 49 plus 14 times 7 is 98 minus 47. Negative 49 minus 47 plus 98 gives you a positive 2. So my vertex is going to be 7, 2. I don't know about you, but I'd much rather do this kind of algebra than this kind of algebra. Both will get you to the same answer. But this one's a little bit more computational. Now, this problem is not going to ask us to graph, but it is going to ask us for a lot of different pieces of information, and I need to show you that you can actually find all these pieces without graphing. The vertex was the first one. The next is going to ask us if we have a minimum or a maximum, and it wants to know where it happens and when, the value of it. So without graphing, because if I want to graph it, then I have to move stuff around. Can you tell me whether or not we have a min or a max just by looking at the function? How do you know it's a max? Because a is negative. Our a equals negative 1, which is less than 0. That means we have a downward-facing parabola. And if we have a downward-facing parabola, that means we have a max. We have a maximum that happens at x equals 7 with a value of what? Value of 2. But we know whether it's a max or min solely based on what the value of a is. And something that we haven't really examined yet is we can actually determine the range of our function. Remember that we have domains which tell us our x values, and for parabolas, the domain is always negative infinity to positive infinity. All of our x's will be considered. But our range is dependent upon where our parabola starts. But even without graphing, I can find out what the range of this is because I know that we have a downward facing parabola. I know I have a maximum value. I know I have a top value that my y values can go. It's 2. So that's as far up as I can go for my range is 2. And then after that, if I have a downward facing parabola, what would be my lower limit? Negative infinity. That's exactly right. So even without a picture, we can graph, or we can come up with the range of this because our range is determined solely based on the vertex. And knowing that information and having the general picture of a downward facing parabola, we can come up with intervals of increasing and decreasing. So increasing is where our graph is getting larger or rising as we move from left to right. So if we think about our graph, it's going to be kind of divided between the left half and the right half with the vertex in the middle. So on the left side of our graph, notice we are increasing. So it increases. This is going to affect our x's. It increases from negative infinity until we hit what x value? 7. Do we include that 7 or do we leave it with a parenthesis? Okay, we'll come back. What about decreasing? What's our interval of decreasing then? Okay. And infinities are always used with parentheses. So now 7 fell both as our lower limit of our decreasing and the upper limit of our increasing. So do you think we bracket it or parenthesis it? Parenthesis, because you can't be increasing and decreasing at the exact same time, so we use a parenthesis. And we just found out all of this good information without a graph. Really, we found out all this information just solely by finding the vertex. And this negative b over 2a and the f of negative b over 2a is so nice. You could have used that up here and not had to worry at all about the fact that a was 1/2. It still works. Are there any questions about how we use this? All right, let's flip over and do our one-word problem. Height of a rocket. Some of your problems, some of the other versions can be shooting an arrow. That's a really common one. Somebody shoots an arrow into the air. Somebody throws a rock over a cliff or tosses a ball into the air. Those are kind of the 3 most common versions of this problem. But this one's a rocket. And so it says, a model rocket is launched with an initial velocity of 100 feet per second from the top of a hill that is 20 feet high. Its height in feet at t seconds after it has been launched is given by the function s of t equals a negative 16t squared plus 100t plus 20. Determine the time at which the rocket reaches its maximum height and find the maximum height. Now, that's a lot of information. So I'm going to draw a picture because I like pictures. There's my cliff that is 20 feet high. And I'm shooting a rocket. Gravity will eventually pull it back down. That's all I really know. Based on this picture, you can kind of see it's going to do a parabolic arc, which hopefully is a little bit logical. But if you didn't know it was going to do a parabolic arch, the fact that we have a t squared tells us it's a parabola. The fact that our a is a negative 16 tells us it's a downward-facing parabola. So we do have a quadratic function that we are playing around with. And at some point, before gravity overcompensates for the power of the rocket, there will be a maximum. That's what's going to happen. And as we've seen with our parabolas either have a relative minimum or a relative maximum, and those always occur at a special point called the what? Vertex. Always. So what we have to do is we're finding the vertex. That's all we're doing for this problem. All these big words and all this, physics-looking stuff, and really we're just finding the vertex. That's all we got to do. So our function is this s of t equals negative 16t squared plus 100t plus 20. So based on this, I know that I have an a equals a negative 16, b equals 100, c equals 20. And I know that the maximum is going to happen at a specific time, because it says determine the time at which the rocket meets or reaches its maximum height. That's our time. Notice that t lives inside the function, because that's the x value. So that's going to be the first thing we find. And then we have a max value of our y. So we are finding that vertex. Vertex is negative b over 2a, and then f of negative b over 2a. Or if you want, you could write that as an s, because our function is given to us as s of t. So the first thing I'm going to find is I'm going to find how long does it take our rocket to get up to its maximum height. That's our negative b over 2a. Well, our b is 100, so that would be negative 100 over 2 times our a, which is negative 16. Negative 100 over negative 32. And 9 times out of 10 in this class, we would just want to keep simplifying that fraction and keep it as a fraction. But this is a word problem. It will ask you to round to a certain number of decimal places. We are going to round to 3 and actually find how many seconds it takes. So if I type this into my calculator, I get 3.125. So what this tells me is that the maximum height of my rocket is reached at 3.125 seconds. So just a little bit over 3 seconds after it takes off, it's going to reach its max height. So then in order for me to find out what that maximum height is, I need to plug that into our function. I'm going to call it s of the 3.125 just because they gave it to us as an s of t. That'll give me negative 16 times 3.125 squared plus 100 times the 3.125 plus 20. Definitely want to use your calculator for that. We're going to round to 2 decimal places. I feel like that's the only number of decimal places you get. So this tells me my maximum height. 176.25 feet. So even when it comes to these problems where you might think, man, I'm not good at physics, I don't understand physics, we don't actually have to consider anything physicsy with this because it's just a quadratic function. And we can do the information here because in math land, you get to negate things like gravity or friction or air resistance and things like that that would actually affect how quickly the rocket reached its height or how quickly or how high it got and things like that. We don't have to worry about any of that in math. We just do the algebra and find out the information behind it.